Hi everyone, hope you guys are staying healthy. So, I'm going to start chapter 8 confidence intervals for one population mean. Actually, if we consider about this population mean, we have done this population mean so many times in our chapter 2, 3, something like that. Um, we are now trying to uh, calculate this population mean or try to estimate population mean. Actually, when we are going to subsection this 8.1 estimating a population mean, actually there are two ways to estimate this population mean. One way is confidence interval in this big guy, or the other way is point estimators. So we are going to talk both stuff what we have to use in population mean, estimating population mean. Okay, as I mentioned in chapter 7, if you remember, we discussed about sampling distribution of sample means. Remember that this is not just a sample, this is about sample means. What is this sample means? If we get a few samples and calculate the mean, if you remember, this is x bar. So we calculate different x bars like uh, x1 bar, x2 bar, so on, and then calculate the mean of these x bars. So we call it, let's say, giant x bar. So this is called the sample mean of means. Anyway, we talk about this in chapter 7, and we saw that how this normal distribution work on these sample means. And I told you something about sample size. We can approximate to normal distribution as long as the sample size, let's say simple n, it is at least 30. So if my sample size is 30, I can approximate that my distribution is normal distributed. Got it? Okay. At the same time, I told you that we consider this sample means equals to the population mean. You can see here mu x bar equals to mu. Mu is the population mean. So, and also standard deviation. Sigma x bar we can calculate by sigma, which is the population standard deviation, divided by square root of n. This is what we have done in chapter 7. So you need this idea to move on chapter 8. Okay, first thing, point estimate. Why we use this kind of estimators? To estimate population mean. This point estimate of a parameter, it is a value. Remember that this point estimate is just a value. So it used to estimate the parameter. This is the idea behind this point estimator. It is just a value. Uh, we can calculate this population mean mu without taking census by simply taking sample mean mu x bar, because you remember that mu x bar equals to mu. Okay, so point estimate case, mu is equal to x bar. So whenever you get x bar, okay, it's equals to mu. Okay, then my distribution or my sample, it follow a normal distribution if my n in mean sample size approximately about 30. Okay, there is no fixed delimiter, but approximately 30. In this case, sometime we can use just point estimate, just a value. But in some case, we will be having some kind of range. So some kind of range, a value, let's say val 1, val 2, two values. So this kind of range we called confidence interval. It is a, it is an interval. Okay, so as I mentioned, I told you two things we are using in this chapter: point estimate and confidence interval. Okay, uh, I know you have seen this before, but you don't remember this right now. Confidence intervals we have used in so many places. Like in here, you can see the news reports. Confidence intervals. Sometimes they give or they interpret their values like using a range. See, print they will state plus or minus. See, plus or minus 3%. The value, real value is 42%. Actually, I'm not going to through this example, but just try to focus on specific values. So value is 42, but they have mentioned they will state plus or minus 3%. So we can interpret, or we can simply write these values within a range like this: 42 minus 3, 42 minus 3, comma, the other case is 42 plus 3, two cases. So this is the minimum value and this is the maximum value, which means this is 39, this is 45, something like that. So within a range. See, it's a range. Confidence interval, simply we call CI, confidence interval. Okay, it is just try to get a just idea. Okay, don't we don't need to go through that. Okay, let's see some examples about point estimate. Here you have I think 36. Yeah, you have 36 observations here in this table, and I need to calculate the mean. Okay, I can calculate the sample mean, which is x bar. How we calculate it? Summation of these values divided by number of instance or number of data you have. Okay, there are 36. So n equals 36. So summation of xi, summation of all these values, it becomes 2278. So n is equal to 36. You can get this value 63.28. So this is your x bar. Since my n is greater than 30, greater than or let's say equal 30, I can approximate this is like normal distributed. So mu is approximately this much, which means this value 63.28 thousand. So we can consider mu is approximately this one. Why? I have n equal 36, so I can approximate this to normal distributed, and mu, why mu? Mu x bar equals mu. Remember this one. So this is my mu x bar here, so equals to mu. Okay. Okay. Let's see some definitions what we are using here. Confidence interval. See, confidence interval. It is an interval. It is an interval like this. There are two numbers: minimum value maximum value. So simply we call it's an interval. It's an interval of numbers obtained from point estimate of parameter. So this is really important. We get this confidence interval by using point estimate. So minus point estimate minus something, point estimate plus something. So this is the way how we get this confidence interval. So a few slides later you will see how we get that, but for now remember this one. We use point estimate to get the confidence interval, or simply called CI. Okay, confidence level. Actually, confidence level is the something like uh, confidence interval contains the parameter. Confidence interval contains the parameter, something like that. So confidence level is a value. Confidence interval again is a value. The parameter it lies in the confidence interval. So parameter which is inside the confidence interval we call confidence level. Okay, so this is a combination of these two, so just check it out. There are one more thing you should know. Basic equations. Point estimate, again it's a value. This is my point estimate, and there is something we call error, plus error, or we can do the same thing by subtracting from this value. This is again my point estimator, same point estimator, minus error. So do you feel something? Value comma value. See, point estimator, point estimator. If you remember in last slide, I told you we use point estimators to calculate the confidence interval. So this is some kind of confidence interval. So what is this error? You will see what is this error a few slides later, maybe in next chapter. Okay, same margin, we call this actually error, a special name margin error. Okay, this margin error you can calculate by using uh, table value times standard error of the point estimator. Don't worry about these names. You will see what are these later. This table value mean table value like C table, like T table. You will cover these two later. Okay. Okay. Confidence level. Do you remember this guy? Confidence level, who lives inside confidence interval. Okay. Okay. See, check this one. Confidence interval. There are few confidence interval values. They are percentage. Confidence intervals we represent by using percentage. Okay. So please remember this one. Confidence interval we always mention by using percentage. See, 99%. So confidence level we may get the value like probability value. See, 0.99. Percentage simply divide by 100, you can get this confidence level. Okay, same as here, 95% confidence interval, which means 0.95 confidence level, CL. Okay. Okay, so always remember confidence interval using percentage, confidence level using decimals, 0.99, 0.98, whatever with respect to this confidence intervals value. Okay, if you remember this guy, try to remember this guy, C alpha. Do you remember C alpha? Alpha we used to get the area, right? This is my alpha. Do you remember that in chapter 6 we did? This is alpha, which means this area, right? Same here. Alpha is the area, but in this case you can calculate your alpha by using confidence interval. There's a very straightforward relationship between confidence level and alpha, which means alpha equals to 1 minus your confidence level. Okay, for an example, let's pick second one. See, 0.98 is your confidence level, this guy. So 1 minus 0.98 is my alpha. Okay, so please remember this one, alpha. There is a linear relationship between alpha and confidence level. So 1 minus confidence level equals to alpha. Okay, which means simply if you consider this one with this, in this case this is my alpha, this colored area. So this is my 0.98 area which I haven't colored. Okay, so you can get this one from negative infinity to this point. It has covered 98%. Okay, so that's the idea. If this is alpha, this is 1 minus alpha. So what is 1 minus alpha? It is this one, which means 0.9298, sorry, 0.98, because my alpha is 0.02. Okay, okay. Last thing, anyway, if we have this kind of point estimators, this kind of interval estimators, whatever, we should interpret them at the end of the day. Okay, that's our purpose. So let's check this one. I have suppose you have taken a random sample of 40 students. So you have 40 students, which means n equals 40. Okay, just take notes. Find the sample mean they have given. It is 73. Okay, this is your point estimate. So you can calculate your confidence interval like this. How you get this? Okay, consider your standard error SE is equals to 3. How we get this one? You will see later in next chapter. You will see how we get the standard error or margin of error. Okay, under 95% confidence interval. Okay, under 95% confidence interval. So it is a percentage confidence interval. So 70, I need some space. Okay, I'll write somewhere here. Okay, 73 is my is my point estimate. So it is 73 plus your standard error 3, and again 73 minus 3. This is an interval. This is an interval. So this is your confidence interval. I'm sorry, it's really hard to write on the screen, but I'll try to manage it. This becomes 70. This becomes 76. So that's how we get this interval. Clear? Uh, your point estimate. Your point estimate. This one plus or minus standard error. Plus or minus standard error. Okay. Here I have considered the standard error is 3. Okay, this is something they have given to you. So how we interpret them in general, you are 95% confidence that, why 95? Because that's the confidence interval, that the population mean test score is between, see, it's between score 70 and 76, these two values. 70 and 76. Okay, when we think about this mathematically, it's huge. If we find sample mean all the possible sample for 40 students, for each in okay 95 confidence interval for each sample mean, the 95 interval will actually include population mean test score. 5% will not include population mean test score. Why this 5%? Because 95% is included into this case, but the rest of 5% will not include. Okay, so just forgot this one. You don't need this one. Okay, I think you may have a, a rough idea. That's fine about this, how we estimate the population mean. So my goal is to help you to understand the materials what we have done here. Okay, see you in next video. Thank you. Stay safe.